We're now going to look at Chapter 10, Lesson 6, Video 5, Converting Complex Numbers into Exponential Form. To do this, let's look at the power series that we've developed already in this chapter. First, we looked at powers of e to the x. Well, I decided to then find out what is e to the I pi. So I pi becomes the x. And we fill it into the powers of e power series, and this is what you get. If you look at this closely, you'll notice something. That if I look at all of the even powers, that's nothing more than the cosine power series. If I look at the odd powers, lo and behold, that comes out to be the sine power series, except it's multiplied each one by I. So from this, we see that e to the I pi is equal to the cosine of theta plus I sine of theta. Means that if we have a complex number, that's equal to r times the cosine of theta plus I sine of theta when we find the radius and degree. And now we realize up above that that means that that's equal to the radius times e to the I pi. So a complex number, if I can find the radius and I can find the degree of it, I can write it as a power of e. This is a very powerful tool to be able to use in terms of advanced mathematics calculations. Let's do a couple so that you get an idea of how it works. We are going to go complex number to sine and cosine representation, then to the exponential notation. The first complex number I'm going to look at is 1 plus the square root of 3i. You see that I'm going to need to find the radius. We know from before that the radius is equal to the square root of a squared plus b squared. So in this case, that's the square root of 1 squared plus the square root of 3 squared, which is the square root of 1 plus 3, which is the square root of 4, and that has the value of 2. So the radius is 2. To find the degree we learned from triangle trigonometry, where we have opposite and adjacent. This is BI, this is A, there's my angle. That theta is equal to the inverse tangent of B over A. So we're going to want to find the inverse tangent of the square root of 3 over 1. If we look on a chart or we do the calculations on our calculator, this will come out to a number which we'll discover is pi divided by 3. If you do that on a calculator, multiply by 3 and you'll get pi, and that's how you know that it'll be pi over 3. So now I have the radius and I have the degree. So now this has become 2 times the cosine of pi over 3 plus I times the sine of pi over 3. I've now written it using its trigonometric values. Now we can write that in its exponential form. The radius is 2. E to the I, and the degree measure is pi over 3. These are the steps. Step 1, find the radius. Step 2, find the angle. Step 3, put in trig form. And then here you can identify the radius and the angle, and then you can write step 4, write in exponential. Right? That's one example. Let me do another example just so that you see some more examples. Let's take a look at this one. 3 minus 3i. Okay, to find the radius, it'll be the square root of 3 squared plus negative 3 squared, which is the square root of 9 plus 9, which is the square root of 18, which simplifies to 9 square roots of 2. Now we'll find theta. Theta is the inverse tangent of negative 3 over 3. When you do this on a calculator, you'll get a value that you'll see as negative pi over 4. Take the value on your calculator, multiply by 4, and you'll see that it's pi. But it's negative, and we want our angle to be positive. Well, since the tangent is the same on opposite points of the circle, we'll just add pi to this, and we'll use the angle then 3 pi over 4. So now we can write it in trig form. That's the radius is 9 square roots of 2 times the cosine of 3 pi over 4 plus I times the sine of 3 pi over 4. Writing it now in exponential form, this will be 9 square roots of 2 times e to the I 3 pi over 4. And that's how we convert from a complex number into exponential number. I want to conclude with a rather interesting observation and story. I looked on the internet to see if I could find the names involved. I could not, but I am going to show you something. What is the value of e to the I pi? Well, e to the I pi would be the cosine of pi plus I times the sine of pi. The radius is 1, so I don't have to worry about it. Cosine of pi is negative 1, the sine of pi is 0, so this comes out to be negative 1. This means that if I bring the 1 to the other side of the equation, I get something called Euler's formula, one of the most famous formulas in mathematics. E to the I pi plus 1 equals 0. This is such a unique formula. It has the 3 basic operations of mathematics: addition, multiplication, and exponents. Division and subtraction are just subcategories of addition and multiplication. Square roots are a subcategory of exponents. And it has the 5 foundational numbers of mathematics: e, which is the natural base; I, the complex number, imaginary number; pi, the ratio of the circumference to the diameter of a circle; 0, which is the additive ID; and 1, which is the multiplication ID. That these 5 numbers with the basic operations combine in this most elegant and simple of formulas. In Russia in the late 1800s, there was to be a debate between a person who was going to argue for the existence of God and one who was an atheist who was going to argue against the existence of God. Well, the one who was arguing for God said, "Why don't you go first?" So he let the atheist go first, and he gave a very lengthy argument about all these discussions about why God does not exist. Then the person who was going to argue for the existence of God was a mathematician. He walked up to the board and he wrote Euler's formula on the board. He actually wrote it as e to the I pi equals -1. He wrote it on the board, turned around, and sat down. He never said a word. The audience stood and applauded as he won complete victory over his opponent, because it pointed out that in mathematics, how can these numbers be so simply combined into a most elegant formula unless there was a designer behind all of creation? So in mathematics, especially at Euler's formula, we find that God has spoken to let us know that he exists.